Well, welcome back to Chapter 13. This is the last chapter in our cruise planning course, and we're going to talk about weather tonight. Weather. Weather in the United States, we're going to talk about professional forecasts, watches and warnings, other weather planning information, USPS weather seminar and course information. We're not going to teach you to be a weatherman or a meteorologist, but we want to try to give you an overview of the nature of weather and the information that you can pick up just by observation. The weather patterns in the United States are part of a global circulation. Air heated by the sun's rays at the equator are circulated to the upper atmosphere and ultimately to the northern latitudes. This cooling air subsides, creating high-pressure systems that move toward the air that has risen and thusly created a low-pressure area. Since air on the surface will move to replace the air that has risen, the movement is from a high-pressure area to a low. And to this, the Coriolis effect, which means that air moving from a northerly direction from the equator will have a tendency to turn to the right in the northern hemisphere due to the rotation of the Earth. And then you have a general movement of weather systems from west to east in our middle latitudes. Hence, weather systems in the U.S. move generally from west to east. So let's talk about the global air circulation. And since the energy of the sun is concentrated at the equator is heated more. And we know that heat rises, hot air rises. There's always low pressure area in the equatorial region by low pressure, which means air is rising as a movement up as opposed to descending, which causes a high pressure area. Air rises over the equator and descends at the poles and at approximately 30 degrees north and south latitudes. And 30 degrees north for us is a latitude right about New Orleans, Houston, Jacksonville, Florida. That's about the 30-degree latitude. And so when we do our weather forecast, you notice we're always watching that weather that starts down in Texas, down the Gulf of Mexico. The descending air at 30 degrees in the poles creates areas of high pressure. And let's see, I think the northern border for the United States is the 48th parallel. But notice the circulation patterns on this slide. You've got areas of rising air, areas of descending air, and you've got really high circulations from the equator all the way to the poles. And that's the source of our polar highs. Global circulation again. The temperature of these air masses also becomes a major weather factor. The air at 30 degrees north latitude will be warmer than the air at 60 degrees north latitude because most of the U.S. is located between these two areas of subsiding air, hence the name middle latitudes. This becomes the battleground of warm and cold air masses. The boundaries of these air masses are called fronts. It is at these boundaries that we have changes in weather frequently preceded by precipitation and storms. The frontal area is usually associated with a low pressure system where warm air is slowly rising over cool air, and that causes cloudiness and periods of rain. This is followed by warm temperatures and unstable air just before the cold front moves in. Rapidly rising air causes the cold air mass, pushing the warm air upward, can result in thunderstorms. Depending on the temperature difference, severe thunderstorms or tornadoes might occur. The clouds can tell you where you are in this weather pattern, as each system marches across the U.S., sometimes from the southeast, sometimes from the northwest. Rainy, cloudy weather is followed by clearing and then a cloudless sky. As more moisture enters the atmosphere, puffy white clouds called cumulus appear more frequently. Later, high clouds called cirrus appear and can forecast a change of weather within 48 hours. Subsequently, stratus and low clouds move in and bring showers or rain. This pattern repeats itself throughout the year. This slide 6 shows, we're talking about the surface wind flow. On a surface weather map, isobars are lines of equal pressure. Winds blow from a high pressure to a low pressure. Winds turn to the right in the northern hemisphere, and the winds cross the isobars at an angle. And you'll notice here that the isobars, air flows in a clockwise motion out of a high, flows out of a high, and is pulled into a low in a counterclockwise. That's why they call it a cyclone. Okay. Slide 8, this is a supplemental slide, and you kind of have to look at it and spend some time looking at it. This slide's another illustration of how the upper air flow is smoother and more stream-like than lower air flow. One reason for the difference is the absence of surface friction aloft. Winds aloft, upper air winds move along freely with no friction. Pressure gradient force, we call that pressure gradient, that's a difference between the barometric pressure in the center of a high to the barometric pressure in the center of a low. The difference of those is the pressure gradient force is pushing the winds away from the high pressure area toward the low pressure center, but Coriolis effect is turning it to the right just as strongly. And Coriolis' effect is the effect of air that moves from the equator north, it turns to the right due to the rotation of the Earth. The balance between pressure gradient force and Coriolis effect results in winds flowing around high and lower pressures areas rather than spiraling away from or into them. Winds near the ground, surface friction slows the wind's speed. Slowing the wind weakens the Coriolis effect since it depends on speed. Pressure gradient force stays the same. The pressure gradient force, now stronger than the Coriolis effect, pushes the wind away from the high pressure center in an outward spiral, and the wind towards the low pressure center in an inward spiral. Wind on the surface is not only slower than the wind high above, it blows from a different direction. This slide also refers to convergence and divergence aloft, a matter that will be discussed in more detail in Chapter 6. Now, that's if you're taking the weather course. Slide 8. This concept is a good one to put away and file away for reference, because this really works. It's called the Ballot's law. And there's a Dutch meteorologist, Ballot, pronounced Ballot, in 1857 developed a method known as the Ballot's law for determining the direction of a low pressure center. So to determine that direction, stand with your face to the wind and position yourself. You can hear the wind over your ears and say, my face is directly into the wind. Hold your right arm straight out to your right side, and then back and move your extended arm backward maybe 15 degrees if you're over open water, or 30 degrees if you're over land past the beam. Your arm should be pointing in the direction of the low pressure center. That gives you an idea of where the center of the low is. And then depending on where the center of the low, over a period of time, several hours, you can, since the low is moving, do this several times, and you can see that, is this low pressure center seem to be moving? Is it going to go over in front of me? Is it going to go behind me? You can get an idea of its relative motion. And that helps you get an anticipation of what the weather is going to be as you develop an appreciation for what the weather is around the various lows and high pressure centers. We're going to talk about cloud types a little bit. Notice on this slide you've got high cirrus clouds, high cirrus stratus, Cirrus are thin, wispy, feathery clouds. Stratus are flat, layered clouds, straight, ladder, flat, Cumulino, lumpy, puffy, woolly. Those are the words that we use to determine or to classify their clouds. Cloud height determined by cloud base. High clouds are 20,000 feet and above. Middle clouds 6,500 to the top of 20,000. Low clouds are below 6,500 feet. Vertical clouds with low bases but high tops. And so you'll notice that the cirrus clouds typically you'll find in front of a low pressure area or a warm front proceeding. That's usually your first indication you've got a warm front approaching. High cirrus clouds, and then as time progresses, you'll know the cirrostratus, then cirrocumulus, altostratus, again, all layered types of clouds, altostratus, and then nimbostratus. Nimbo means rain. And then when you get close to the actual front, you have just plain crappy days, not a lot of wind, and rain, downpours, rain. Professional forecasts, weather reports and forecasts from the internet, weather radio, TV, and fax are invaluable. However, you must have a basic knowledge in order to interpret the report. Will you leave the dock if the report is a 40% chance of thunderstorms? Much will depend on your level of seamanship and experience and the type of condition of your boat. Typically, cruisers are looking for the weather window to open and give you a period of good weather for moving to the next port of call or anchorage. This is particularly important for coastal cruisers, but inland boaters need to be aware as well. National Oceanic and Atmospheric Administration, NOAA, radio broadcasts weather forecast warnings, watches and other information, hazard information continuously 24 hours a day, 7 days a week. Its VHF transmitters broadcast on 7 different channels designated WX1 through WX7 with the frequencies from 162.4 to 162.550. The purpose of the different channels is simply to avoid interference caused by overlapping reception of different area reports. The broadcasts cover all 50 states and adjacent coastal waters. A tone alert is automatically turned on compatible VHF receivers when a severe weather situation develops in the transmitter's coverage area. Marine forecasts from coastal stations also include real-time observations from buoys and coastal installations. Based on demand and feasibility, offshore and open lake forecasts are also transmitted. Typical coverage is up to 25 nautical miles offshore, but is more extensive in certain areas. All VHF handheld receivers designed for marine use can receive NOAA weather broadcasts. National Weather Radio is the primary source for weather updates when on the water. Neighboring countries also have weather forecast capabilities that can assist the cruiser crossing international borders. Thanks to the formation of the North American Ensemble Forecast System, Canada, Mexico, and the U.S. have combined resources to create weather models that forecast out 2 weeks. This enables forecasters in the North America to produce better long-range forecasts. Canada has its own weather radio that uses 7 VHF channels with the same operating frequencies as NOAA, and so the same VHF receiver can be used to receive both Canadian and NOAA weather forecasts. The Canadian Coast Guard Marine Radio is continuous broadcast with warnings of dangerous conditions. The Canadian Internet site maintained by the Meteorological Service of Canada, the equivalent of our NWS, National Weather Service, is www.weatheroffice.com. Marine forecasts are available for the Ontario Lake, the Great Lakes, and Atlantic and Pacific coasts. The Servicio Meteorológico Nacional de Mexico, help me out on that one, National Meteorological Service of Mexico, broadcasts marine conditions from coastal stations. In the Bahamas, local forecasts contain mostly marine weather information. The Bahamian government also broadcasts on single sideband frequencies. The internet websites generally have the highest quality and most detailed weather information, including radar and satellite images. With expanding wireless access to the internet, computers, smartphones, etc., the public has access both at home and abroad, on board. The single most comprehensive website for NOAA is the NOAA/National Weather Service weather page. That's http://www.weather.gov. Local forecasts can be accessed through map pointing and clicking or by entering city and state or zip code information. The same site can be used to get information about river conditions by clicking on water and using the resulting map to get logical existing forecasted river ranges and flow rates. Marine forecasts, unlike regular weather reports and forecasts, NOAA marine forecasts contain detailed information about wind speed and direction, visibility, and most importantly, sea state. Wave heights are reported in feet based on the average height of the highest 1/3 of the waves in a wave train. Higher waves above this average are to be expected. Marine forecasts can be accessed on the internet from the NOAA National Weather page by clicking on Marine in the left column or by clicking on a coastal area on the U.S. map. Below is an example of the new format. So here is NOAA's National Weather Service web page. Okay. Watches and warnings are issued as necessary by the National Weather Service. There is a dilemma in using storm warnings. The wider the area covered, the greater the possibility that some people and businesses will be unnecessarily affected, creating greater avoidable cost and the problem of crying wolf. And two, the narrower the area covered, the more likely that preventable personal and property loss will be higher in areas not covered by the warning. So we're going to talk about small craft advisory. An advisory issued by the Coastal and Great Lakes Weather Forecast offices for areas included in the coastal waters forecast or nearshore marine forecast products. Thresholds governing the issuance of small craft advisories are specific to geographic areas. A small craft advisory may also be issued when sea or lake ice exists that could be hazardous to small boats. There's no precise definition of a small craft. Any vessel that may be adversely affected by small craft advisory criteria should be considered a small craft. Other considerations include the experience of the vessel operator, the type, overall size, and seaworthiness of the vessel. There is no legal definition of small craft. The small craft advisory is an advisory on coastal waters and nearshore forecast for sustained winds, frequent gusts, or sea wave conditions exceeding defined thresholds specific to geographic areas. A small craft advisory may also be issued when sea or lake ice exists that could be hazardous to small boats. Now, in the eastern area, Maine to southern South Carolina, Lake Erie, Lake Ontario, sustained winds or frequent gusts ranging between 25 and 33 knots, except 20 to 25 knots, lower threshold area dependent to 33 knots for harbors and bays, etc., and or sea or waves 5 to 7 feet and greater area dependent. That's a small craft advisory on the eastern side. The central area, Minnesota and Ohio, sustained winds or frequent gusts on the Great Lakes between 22 and 33 knots inclusive, and or sea or waves greater than 4 feet. In the southern area, Georgia to Texas and the Caribbean, sustained winds of 20 to 33 knots and or forecast seas 7 feet or greater that are expected in more than 2 hours, for more than 2 hours. Western, Washington to California, Sustained winds of 21 to 33 knots, potentially in combination with wave heights exceeding 10 feet or wave steepness values exceeding local thresholds. And in Alaska, sustained winds or frequent gusts of 23 to 33 knots. A small craft advisory for rough seas may be issued for sea or wave conditions deemed locally significant based on user needs and should be no lower than 8 feet. Hawaii and the Samoa, sustained winds of 25 knots or greater and seas 10 feet or greater. A gale warning. Gale warning is issued for a tropical system when gale winds of 39 to 54 miles an hour, which would be 34 to 47 knots, are expected. Storm warning issued when winds of 55 to 73 miles an hour, or 48 to 63 knots, are expected. If a hurricane is expected to strike a coastal area, gale or storm warnings will not usually precede hurricane warnings. Hurricane watch issued for a coastal area when there is a threat of hurricane conditions within 48 hours. Hurricane warning issued for a coastal area when hurricane conditions are expected in 36 hours or less. Hurricane conditions include winds of at least 74 miles per hour or dangerously high water and waves, even if winds may be less. Action should be taken immediately to protect life and property. Flash flood watch issued when a flash flood is possible in the area. Tornado watch. Atmospheric conditions are favorable for the development of severe thunderstorms capable of producing tornadoes. And the tornado warning. A severe thunderstorm has developed and has either produced a tornado or radar has indicated intense low-level rotation in the presence of atmospheric conditions conducive to tornado development. So weather planning information. If you're going to make a plan, converting information, where do you get your sources? Pilot charts. We talked a little bit about pilot charts in one of the other sessions. The National Geospatial Intelligence Agency, NGA, an organization within the Department of Defense, publishes the pilot charts in 5 separate volumes. Each volume covers an ocean area like North Atlantic, including the Gulf of Mexico, North Pacific, and so on. The charts assist navigators in selecting the fastest and safest routes based on expected weather and ocean conditions. A volume has 12 charts, one for each month of the year, showing the historic averages for prevailing winds and calms, wave heights, typical barometric pressure, percentage of gales and ocean currents, tracks of cyclones, air and water temperatures, and recommended cruising routes. Pilot charts are primarily for planning ocean passages, but can be useful if cruising along the coast. Coast pilots are published by NOAA, National Ocean Service, in 9 separate regional volumes, describe major coastal features including typical and unusual weather conditions, climate and events that should be anticipated. Coast pilots are issued for the United States coastal and intercoastal waters and the Great Lakes. Regional knowledge. Various regions of the country have certain weather patterns that recur with some regularity. Knowing and understanding these patterns can help you recognize the weather patterns in boating areas that are familiar to you, as well as to anticipate weather patterns when you travel to new and unfamiliar areas. Local knowledge, that's the typical time and nature of the local sea breeze prevalence and time of local thunderstorms and typical sea conditions with various wind directions are usually matters of common knowledge available from residents of an area. Competitive sailors from local clubs are typically quite expert at local wind conditions and shifts. Over time, a student's own experience in an area should develop into local knowledge. So slide 15, take a minute to look at this. This slide 15 is like a cross-sectional area of there's a cool air mass, and notice the indication of you are here on the right side. So if you're here, you're basically in this cool air mass. As you look aloft, you'll notice the cirrus clouds probably really high. There's a approaching warm front. And the center, or the boundary between the approaching warm air mass and the receding cool air mass is about maybe 600 miles away. Your barometric pressure, your barometer, is probably high, and you can anticipate rain maybe in 15 to 24 hours. Notice that as you go from 600 to 500 miles to 400 miles and so forth, the cloud type has changed from the high cirrus wispy clouds, maybe a ring around the moon at night, to cirrostratus. Now we're seeing some layered clouds, and that's just like a carpet, not much definition of the clouds. And then you got stratus clouds, are a little darker, a little lower. Again, not a lot of wind. The wind direction maybe has changed from a southerly direction, maybe to southeast, and altostratus. And then when you get down within 100 miles, it's going to rain. Rain's on the way. You notice that the wind is more east, and your cloud type has changed to nimbostratus, and that's just dense, dark clouds, and the rain is just going to be a steady rain. Not a lot of wind, not a lot of howling. No, typically you don't have thunder and lightning. You just have those days when it just pours. And this is the day you want to hunker down and just sit and read a book. Notice how the barometric pressure has dropped during this time. Okay. And let me read the notes that go with this. The warm front moves from west to east, which is left to right. The warm air mass slides up a cooler wedge of air. The progression of stratus-type layered clouds begins lowering well before the surface front. A steady rain begins closer to the surface front. The wind veers from south to southwest. The pressure falls. Now, when the wind veers to southwest, what they're talking about, that's right at the frontal boundary. When that warm front, when you have frontal passage, the wind should shift from southeast to southwest. So now let's look at the approach of a cold front. And I'm just going to read the notes that go with this, and I'm going to have my own comments. South of the low of a cold front, again, notice that you are here. The cold front moves from west to east. Cold air mass pushes the warm air mass up abruptly as it advances. Vertical type clouds, cumulus and cumulonimbus, form. Rain can be hard and winds turbulent as the thunderstorms near the front. The wind veers from southwest to west, right at frontal passage, as the front passage. Behind the front, in the cold sector, the air mass is cold and dry. And I think we probably all experienced that condition in this location on this slide, like you are here. It's probably a nice day, and you notice as the clouds approaching from the west, you've got these big cumulonimbus, the big anvil-shaped clouds. You know, those are produced by vertical motion, and you've got, I really wish you'd take my weather class so we could talk about latent heat and heat being released when water changes state and makes this act like almost like gasoline. It's an accelerant that forces the vertical motion of these clouds. But then you wind up with winds kind of south-southwest. You start getting heavy rains, thunderstorms, all the turbulence, and then as the barometric pressure drops, right about frontal passage, you'll have an abrupt change in wind direction from southwest. The wind will go west. And if you think about it, I'm sure you've all experienced that. No. And then the wind will go west. It will clear up. The wind air masses will be cool and dry. And the sun will come out and be nice and bright and sunny. Let's talk about the NOAA weather radio. We talked about it a little bit with the communications section. But NOAA radio, National Weather Radio, it's a boater's best friend. It is the main source of weather information for recreational boaters when they're out on the water. NOAA Weather Radio, broadcast 24/7, has 7 VHF channels to avoid interference from overlapping areas. Covers all 50 states and coastal areas. Broadcasts tone alerts that will warning of severe weather if the radio is equipped, and forecasts river conditions in river areas. All handheld radios and other marine VHF radios can receive NOAA broadcasts. And the national, or NOAA and U.S. Coast Guard marine forecasts. NOAA marine forecasts are the main source of marine reports when out on the water. Typically cover up to 25 miles offshore, as we said before, and include buoy information and emphasize sea states, visibility, and winds. Gives you a wave height, reported wave height, which is the average height of the highest 1/3 of the waves. The shorter the period, the steeper the waves. Now, the U.S. Coast Guard sends urgent weather alerts on channel 22A, we call it 22 alpha, after the initial alert on 16. Check your radio when you have a chance, and I noticed this, that there are, most weather radios have an international or a U.S. Group of frequencies. If you're using the international frequencies, you won't find 22A on your radio. And so if you're hearing a weather alert on channel 16, so for more details, switch to 22 alpha, Coast Guard out. And then you go to look for 22A and you don't have it on your radio, you're using the international setting, your international set of frequencies. So you need to change that setting on your radio. Here is a National Weather Service web page. And you notice this, you've probably seen these forever, but now with the knowledge of the blue lines with the sharp points, those are cold fronts. And so from the last slide, a few slides ago, there's thunderstorms, there's vertical motion, there's clouds there, vertical clouds there. Where you got your lows, and let's follow this low up, or this front up through Ohio. You notice that up there that changes color to a magenta color. That's an occluded front. That's a place where the cold front has caught up with the low pressure center, the warm front, and has driven all that air aloft. That's usually where you have some pretty nasty weather. There's an additional section here that shows main portals of weather. It shows a national weather map, now a detailed 7-day forecast for the Cleveland area, and then another click with that. This is all information you can get from these pages. Here's now is a radar image of the same area that's being covered. So I'm sure you're all familiar with this. The National Weather Service Marine Web Pages, all marine forecasts for the U.S. can be accessed from www.weather.gov/om/marine. This slide shows the regional coverage for the Great Lakes. And that gives you an idea of where those stations are based out of. Like most of our weather up in the Apostle Islands, kind of the National Weather Service out of Duluth. And then another one will be out of Marquette. Another one will be out of Milwaukee. One out of Chicago. One out of Grand Rapids. Northern Indiana. Gaylord. Detroit, Pontiac. Cleveland. Buffalo. And then those are the different zones where the weather broadcasts are stationed from. I'll let you just take a peek at this slide here. And then you got the local forecasts that are coming out of each of those things for the different areas. And the other thing you've got is SiriusXM and satellite services. I don't have the benefit of first-hand knowledge with this, but typically Sirius Satellite Weather Radio Service has over 180 radio channels for entertainment, news, etc., but a private marine weather subscription service is available. A special receiver and antenna is required. There are continuous weather data and geographic updates. There's both offshore reception and weather data coverage. Radar images, for example, are available for up to 150 miles offshore in some areas. The weather graphics can be overlaid on chart plotters and computer navigation programs. So something worth checking into if you plan to be offshore. With that concludes my comments and the slide information for Chapter 13, and we hope you've enjoyed the time we've spent with the cruise planning class. See you when we have questions.